Okay, so this is a guided walkthrough for the TryHackMe Advent of Cyber, Day 6. The exercise is in the Sandbox category, and Day 6 it says, if I can't find a nice malware to use, I'm not going. All right, so let's read the text. Mayor Malware is scheming, full of delight, to ruin SOCMIS and frighten SOC teams. But Glitch and McSkitty had spoiled his plan by discovering secrets that exposed the man. Mayor Malware slammed his hand on the table, his eyes narrowing as the report flashed on his screen. Glitch and McSkitty had uncovered his trail. He took a deep breath, calming himself. No matter, he muttered, a sinister grin forming. They may have found me, but haven't stopped me. His confidence stemmed from the malware he had crafted, so devious and advanced that it would easily evade detection. But before unleashing it to wreak havoc on SOC teams and ruin SOCMIS, there was one final step. He needed to test it in a sandbox. So what are we learning in today's lesson? Learning objectives. Analyze malware behavior using sandbox tools. Explore how to use Yara rules to detect malicious patterns. Learn about various malware evasion techniques. Implement an evasion technique to bypass Yara rule detection. Connecting to the machine. Before moving forward, review the questions in the connection card shown below. Do I need to start a VM today? Yes. Is there split screen available? Yes. Am I given credentials to connect directly to the VM via RDP, VNC, or SSH? Yes. All right, so it says click on the green Start Machine button to start the virtual machine in split screen view. So let's click on the green Start Machine button now. And that's going to start up the virtual machine associated with today's task. We don't need to start up the attack box to interact with this machine, but the machine is going to take a couple of minutes to load up. So in the meantime, let's read a little more about what's going on in today's task. Okay, so here we're talking about detecting sandboxes. A sandbox is an isolated environment where malicious code is executed without affecting anything outside the system. Often multiple tools are installed to monitor, record, and analyze the code's behavior. Mayor Malware knows that before his malware executes, it needs to check if it is running in a sandbox environment. If it is, then it should not continue with its malicious activity. To do so, he has settled on one technique, which checks if the directory C program files is present by querying the registry path. This one over here, HKLM software, Microsoft Windows current version. The value can be confirmed by visiting the registry path within the registry editor as shown below. To open the Windows registry editor, navigate to the Start menu on the bottom and select Run, enter regedit, and press Enter. So we can't do this yet because our machine is still loading. So to open the Windows registry editor, navigate to the Start menu on the bottom or select Run. So we're just going to, so this is a Windows VM over here. We need to navigate to the Windows key over here and click on it. And then we can navigate down to Search. So after you click on the Windows key, you can navigate down in the menu and click on Search. After you've done that, you can search for the program which is called regedit. And then you're going to see Registry Editor pop up. So you can just click on that. And then we're going to look for this particular value over here. So it's going to be local machine software, right? So we just need to click on software, just double click on it. And then after that, we're going to go down to Microsoft. So Microsoft, double click that. And then after Microsoft, it's Windows. So scroll down. Scroll down to Windows over here. And then double click that. And then it is current version. So current version is over here. Double click that. And then there's going to be this value here, which is program files directory. Program files directory here. And we can see that the value in this is this over here, C program data, C program files. So this is what we're talking about when the malware is looking for this entry in the registry. So to open the Windows registry edit, okay, we've done that. Here's what it looks like in the C programming language. So I think what we're looking at here is the code inside the malware that checks whether or not this registry value is valid or not. Okay, so don't worry, you don't need to understand every detail of the code. All you need to know is that the function is designed to check the system's registry for a specified directory path, program files dir. This path's presence or absence helps the malware determine whether it's running inside a typical or virtualized environment like a sandbox. Can Yara do it? Mare Malware knows that McSkitty is a big fan of Yara rules. Yara is a tool used to identify and classify malware based on patterns in its code. By writing custom rules, analysts can define specific characteristics to look at, such as particular strings, file headers, or behaviors, and Yara will scan files or processes to find matches, making it invaluable for detecting malicious code. Mare Malware does not think such a simple tool can detect his malware, but just to be sure, he has to test it out himself. To do this, he wrote a small script that executes a Yara detection rule every time a new event is added to the system monitor log. This particular Yara rule detects any command that tries to access the registry. So let's have a look at the rule. So the rule here is called Sandbox Detected. Detects the sandbox by querying the registry key for the program path. Okay? So let's understand the contents. In the string section, we have defined variables that include the value to look for in the command. In the condition section, we define that the rule will match the scanned file, or in this case, any of the specified strings are present. For its testing, Mare Malware has set up a one-function script that runs the Yara rule and logs the true positive in the C tools yaramatches.txt file. Open up a PowerShell window, navigate to the C tools directory, and use the following command to start up the EDR. Okay, so we're going to go into the box over here. I don't think we need the registry editor anymore, so we're just going to close it. And then we're going to start up a administrator PowerShell. So the PowerShell icon is over here. What we want to do is we want to right-click on it and then select Run as Administrator. So that's going to start up our PowerShell. Let's make the PowerShell a little bit bigger so that we're not having problems looking at this thing. We're going to go to Properties, and then we're going to go to Font. And in font, let's make this 20-point font. So, okay, so this is a little bit bigger. Maybe we can make it a little bit bigger still. So Properties, Font. We're going to make this 24-point font. Okay, this is nice and big. All right. Okay, so navigate to the C tools directory. So that's going to be cd, C/tools. And then use the following command to start up the EDR. So it's going to be /jinglebells. /jinglebells. And then hit enter. Okay, no events found in Sysmon log. No new events found. Okay, great. This tool will run on the system and continuously monitor the generated event logs. It will alert you if it finds any activity/event that indicates that the registry mentioned above key is being queried. Now run the malware by navigating over to C Tools Malware and double-clicking on the merrychristmas.exe file. So we're going to do this inside the File Explorer, so just click on this button right here. Then we're going to go to C Tools Malware. So the malware directory is over here. And then we're going to double click the Merry Christmas executable here. Okay. So if our custom script did its job, you should have witnessed a pop-up by our EDR with the flag included as shown below. This will answer the question to question 1 below. You can now exit the custom EDR by pressing Control-C. Okay, so it says here, if the pop-up does not show up, hover over the PowerShell item in the taskbar. It should now show that the pop-up was generated. So the flag that, that the text is referring to, you can hover over the PowerShell icon here, and then click on this notification over here. So it says malicious command detected, THM glitch was here. So this is the flag for one of the questions. So while this information is still fresh, let's answer that question. So in THM, we're going to scroll down to the bottom, and then in the first question here, we're going to answer the question, what is the flag displayed in the pop-up window after EDR detects the malware? So this is going to be THM, and then inside the squiggly brackets, it's going to be glitch was here, like this. Click on submit. Okay, so now we don't need to worry about this. We can just dismiss the notifications. And inside the PowerShell script, you're going to notice that this behavior was detected. So Yara Sandbox result, Sandbox detected. So this ran, and it identified the process that triggered this event as the malware. Okay, so let's go back up. So this section is adding more evasion techniques. It seems that Yara can detect the evasion that Mayor malware has added. No worries, because we can make our malware even stealthier by introducing obfuscation. So we've got a command to obfuscate our malware in some way. So code explanation. It says the above code does the same thing, queried the same registry key to get the information about the program data. The only difference is that the query is now encoded using base64, and the code uses the PowerShell to execute the query. The encoded string can be checked by decoding it using a tool like CyberChef, as shown below. Okay? Beware of floss. While obfuscation is helpful, we also need to know that there are tools available that extract obfuscated strings from malware binaries. One such tool is Floss, a powerful tool developed by Mandiant that functions similarly to the Linux strings tool, but is optimized for malware analysis, making it ideal for revealing any concealed details. To try out Floss, open a PowerShell window and enter the following command. So we need to go to ctools floss and then run floss.exe. Okay, so let's first of all, let's get out of the script over here. This script is still running. We need to get out of it by doing the Control-C keyboard shortcut. Okay, so after that, we see that we are in ctools. We want to go to cd, c/tools/floss. Okay, and then after that, hit enter. We see in here there's the floss.exe binary, which we're supposed to run. So we're supposed to run this command over here, floss.exe, and we're running it on the Merry Christmas malware. And we're going to create a file called malstrings.txt inside the tools directory. Okay, so let's run this. So we can just copy this command over here. And then inside of here, I think we can just paste this in. No, we cannot paste it in. Okay, so it looks like what we're going to need to do is we're just going to need to type this out manually. So it's going to be floss.exe, and then c tools malware /Merry Christmas.exe, and then type it into out file c tools malstrings.txt. Okay, so after we've copied this, after we've typed all of this, hit enter. So the tool is going to take a little while to run. It says the above command can take up to 2 minutes to complete. In the meantime, let's break down the command. So what is it doing? So this command right here, so floss.exe on this file here, merrychristmas.exe, this command scans for strings in the binary merrychristmas.exe. If any card-coded variables were detected in the malware, Floss should find them. So then the pipe symbol is going to redirect the output of the command in front of it to the input of the command behind it, which is outfile into malstrings.txt. We save the command results in a file called malstrings.txt. Once the command is done, open malstrings.txt and press F, Control and F to search for the string mayor malware. Enter the flag as a question to question 2. The format of the string is THM and then the curly braces. So what we can do is we can open up our Finder here, and then go back up to the tools directory. So in the tools directory, there's going to be malstrings.txt. We can click on that. And this is going to bring up a notepad. So in the notepad, we're going to search for mayor malware. So just in the file, do Control F. Do Control F, and then search for mayor malware, and then hit Find Next. Cannot find mayor malware. Were we supposed to search for... And search for the string mayor malware. Let's try going up. Cannot find mayor malware. Okay, let's try... Okay, so we actually can't find mayor malware, but let's try looking for this over here, THM. So THM is the flag prefix for TryHackMe flags. We're going to find this one. Let's try going down. Okay, so we found it. So inside the this malstring file over here, there's THM hidden clue, and this is the flag we're looking for. So we can just highlight the flag here. And then go down to the bottom, because we're going to need to submit this. So what is the found flag in the malstrings.txt document after running floss.exe and opening it in the file in the text editor? So we can just paste this in, THM hidden clue, and click on submit. Okay, after we do that, let's finish off the room over here. Okay, using Yara rules on Sysmon logs. These Yara rules are becoming a pain to malware's backside. If he wants his malware to be undetectable, he needs to research how Yara rules can be used to stop him. For example, his research tells him that Yara rules can be used to check Sysmon logs for any artifacts left by the malware. He'll need to test this as well. Sysmon, a tool from Microsoft's sysinternal suite, continuously monitors and logs system activity across reboots. This Windows service provides detailed event data on process creation, network connections, and file changes, valuable insights when tracing malware behavior. A Yara rule will look for events with event ID 1 process created for this to work. There are many entries in the Sysmon log. To make this easier to find the event that we're looking for, we will apply a custom filter using the event record ID that we can see in the Yara matches.txt file located in C Tools. So open up a PowerShell window and enter the following command to check the contents of the EDR log file. Get content, okay, C Tools Yara matches.txt. All right, so we're going to close out our text editor over here, and we're going to close out our Windows Explorer, both of them, and then we're going to go back to our PowerShell. Okay, so inside of PowerShell, we're going to get content C Tools Yara matches.txt. Okay. So we should get a result similar to the output below. So let's see, event ID 1, event record ID, okay. So the number is different, but it's still command line, register, query, and then this path over here. Yara result, detect, shutdown, time query, C users. Okay, I do not see that. I wonder why. Okay, so note down the event record ID value. We will use this value to create a custom filter in the Windows Event Viewer. Next, open the Windows Event Viewer by clicking on its logo in the taskbar, and on the left-hand side, navigate to Application and Service Logs, Microsoft Windows Sysmon Operational. Okay, so let's do this. Note down the event record ID value. Event record ID value, we're going to highlight this and copy it. Open the Windows Event Viewer. I think this is the Event Viewer icon we're looking for over here. Click on that. On the left-hand side, navigate to Applications and Services, Logs. Applications and Services Logs, so this right here, double-click on that. And then go to Microsoft, double-click on that. And then Windows, double-click on that. And then scroll down to Sysmon. Here we go. So double-click on that. And then Operational. So click on Operational. Continue by navigating to Filter Current Log on the right-hand side of the screen. So on the right-hand side of the screen, there's going to be Filter Current Log. I think this is the button right here. We click on that. You should see a window like the one below. Here it says, okay, so we've got a bunch of, navigate to XML and tick the checkbox Edit Query Manually. Okay, so inside here, there's the XML tab over here. Click on it. And then click on Edit Query Manually here. And then click Yes. Okay, finally copy the following filter into the input box. Okay, if this is not going to paste properly, then that's going to be a big problem, but let's see if it is going to be able to paste properly. So we're just going to, everything here should be the same. Path, Microsoft Windows, Sysmon Operational. Select path, okay, that's the same. So let's try copying this code over here. And then inside the window, we're going to paste. No, it did not paste. Okay, I guess we're going to need to type this out. So, okay, now let's try. Okay, so that took a little bit, but we managed to get there. So replace the event record ID value with the one we recorded above. Apply the filter by clicking on OK. Now you get the event related to the malware. Click on the event and then click on the Details tab, and you should get the following input. Okay, so click on the event and then click on the Details tab. So this event, and then click on the Details tab. Okay, so let's see. Click on the event and then click on the Details tab. You should see the following output. So click on the Details tab, and we see here event data, and what is it here? cmd.exe, Windows command processor. Okay. Okay, so this does look kind of similar. So cmd.exe, Windows command processor. So let's take a look at the event data that is available to us. The parent image key shows us which parent process spawned the CMD process to execute the registry check. Okay, so parent image is parent image is here. So this points to the malware file, which is the merrychristmas.exe file over here. Okay, then the parent process ID and process ID keys are valued for follow-up research. We can also use them to check for logs for related events. Okay, so parent process ID, which is these ones over here. So we could keep track of these numbers in case we wanted to do more investigation. The user key can help us determine which privileges were used to run the command.exe command. The malware could have created a hidden account and used that to run commands. So the user key is up here. So the administrator in this case is the one that ran the command. The command line key shows which command was the command that was run in detail, helping us identify the malware's actions. So the command line is this over here. So it ran cmd.exe and then it looked for the it ran the registry query on this registry key over here. Okay. Let's see. The UTC time key is essential for creating a time frame for the malware's operation. The time frame can help you focus your threat hunting efforts. So UTC time is up at the top. Yeah. So UTC time is this over here. So this is when the process ran. Okay, never gonna give up. His malware, it seemed, wasn't ready for the town. These are watchers and scanners and rules by the ton. If I'm not careful, they'll catch all my fun. Mayor Malware leaned back, tapping his fingers thoughtfully on the table. All of this research had revealed an unsettling truth. His malware, as cunning as it was, wasn't ready for the wild. There were too many tools and too many vigilant eyes. Analysts armed with Yara rules, Sysmon, and a host of detection techniques that could expose his creation before it even had a chance to spread. And I'm not sure but this might be the Mayor malware in question. He clenched his fist, a determined glint in his eye. Just a little more fine-tuning, he murmured. He would study, adapt, and evolve his malware until it was truly undetectable. When the time was right, he would unleash it using upon this unsuspecting SOC teams, striking where they least expected it. But for now, he would wait, watching, planning, and he was perfecting his craft in the shadows. All right, so we're now done the room. So all we need to do to finish the room is to click on this button over here. If you want more about sandboxes, have a look at the room Flare VM Arsenal of Tools. Okay, we click on Complete, and we are done. All right, so that was a guided walkthrough of the Advent of Cyber event Day 6 on TryHackMe.com. And we're going to be doing many more days after this. But until then, we will see you next time.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.